Hi, this is Mr. Backstrom, and today I want to go over a sample problem from section 3.4. This is using the quotient rule to find the derivative of a function. And notice here we have one polynomial over another polynomial. And as long as the bottom polynomial is not equal to 0, we can apply the quotient rule. And by doing that, we kind of treat these as separate functions. And I'm going to give you kind of both the long version and the short version of solving this problem. So the long version is treating both of these as kind of their own separate function, as long as the bottom line is 0, like we said before. So let's say the top, we'll call that g of h, g of x. So let me go ahead and write that. So we have g of x is equal to 2x squared minus 9x plus 1. And we'll call the bottom function h of x. H of x is equal to 6x plus 5. And the formula tells us, once again, as long as h of x is not equal to 0, that the quotient rule says that the derivative of the f of x, so f prime of x, so f prime of x is going to be equal to the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Alright, so in order to do this, what we're going to want to do is also find the derivative of both the top and the bottom function. So we can do that just by using the simple power rule. So the g prime of x, the derivative is, we just apply that power rule, and we're going to have 4x minus 9. And we also need in this formula the derivative of the denominator, which h prime of x is simply going to be equal to 6. Alright, so now let's plug all of this in here. Alright, so f prime of x is going to be equal to h of x, which is 6x plus 5 times g prime of x, which is 4x minus 9. 4x minus 9. Now we're going to have a minus. I'm going to put this in brackets to make sure that we distribute that okay. G of x, which is this function up here. So 2x squared minus 9x plus 1 times h prime of x, which is just 6, all over h of x squared. So that's just going to be 6x plus 5 squared. And so now it's simply just going to be kind of distributing this out and simplifying. So this should be equal to, I'm going to go ahead and leave this factored out. That way, if I happen to get another factor there, I can factor a 6x plus 5 out of everything. So this is going to be 6x plus 5 times 4x minus 9. And this thing over here is going to be minus, I can distribute that 6 in there, or let's see if we can factor that. It doesn't look like that's easily factorable, so even when we distribute that 6 in, I doubt that will be factorable. So let me go ahead and FOIL that while I have the chance here then. So this is going to be 6 times 4, 24x squared, 24x squared. This is going to be 20x and minus 54x, so that will be minus 34x, and that's minus 45. All right, and then this is going to be minus 12x squared minus 12x squared plus 6 times 9 is 54, so plus 54x, and this is going to be minus 6 when I distribute that all in there. All right, all over 6x plus 5 squared. All right, so cleaning this up a little bit, I have a 24x squared and a minus 12x squared, so that's going to be 12x squared, a minus 34 and a 54, so that is going to be a plus 20 plus 20x, and I have a negative 45 and a negative 6, so that's going to be minus 51 all over 6x plus 5 squared. And at this point here, if it looks like I could factor out a 6x plus 5 from the top, I might go ahead and do that, but since 5 is not even a factor of 51, it doesn't look like I could do it. So this here would be my final answer that I would plug in there. There's usually not a lot of use into foiling this out. This is usually a nicer form to leave it in. And plus, you leave it in this form in case we can go ahead and end up factoring out one of those 6x plus 5s. All right, if you have any questions, let me know, and I hope you have a great rest of your day. Thanks.